Hello friends, in the last lecture we have taken some brief information about mathematical logic. Now we shall study how the theory of logic can be applied in switching circuit or switching network. We have seen that a logical statement can be either true or false. That means it can have truth value either T or F. A similar situation exists in various electrical devices. For example, an electric switch can be on or off. In 1930, Claude Shannon noticed an analogy between operation of switching circuits and operation of logical connectives. In an electric circuit, switches are connected by wires. If the switch is on, then it allows the electric current to pass through it. If the switch is off, then it does not allow the electric current to pass through it. Now we define the term switch as follows. Here it is some content of this chapter. Now, a switch is a two-state device used to control the flow of current in a circuit. We shall denote the switches by letters S, capital S, S1, S2, S3, etc. Look at the figure first. Here the switch is closed and it is denoted by S. And look at the figure second. Here it is the switch open, that is off. Consider a simple circuit with single switch S, which is connected to the battery B and other end of the switch connected to the lamp L by wire. Here is the current flow from this way. Thus, if P is the statement, the switch is closed and L is the lamp glows, then P is equivalent to L. We know that the lamp glows if and only if the switch is closed or switch is on. Then current will pass through this switch and lamp glow. Negation P. See look at the statement. P is the statement, the switch is closed, and its negation P means the switch is not open, that means switch is open. Sorry, the switch is closed. Negation P means the switch is not closed, that means switch is open. In this case, the lamp will not glow and thus negation P is equivalent to the negation L. In third point, if a switch is on, then its truth value is T or 1. And if the switch is off, then its truth value is F or 0. Example here. Represent the following circuit symbolically and write the input, output or switching table. Here note that here it is the special type of switches S1 and S2 that are parallel. We know that the lamp L glows if and only if, here it is the three cases are there, both the switches are closed, or the switch, second case, the switch S1 is closed, S2 is open, or third case, switch S2 is closed, S1 is open. And if both the switches are open, then light L won't be glow. It is the solution. Let P denote the switch S1 is closed, Q denote the switch S2 is closed, and L denote the lamp glows. In this case, the lamp glows if and only if the switch S1 is closed or the switch S2 is closed. Thus, symbolic form of the given circuit is P disjunction Q is equivalent to the L. And here is the switching table or input output table for the given switching circuit. Here is the P disjunction Q. Now, if the switch S1 is closed and Q also denote the switch S2 is closed, that means both the switches are closed, obviously light will glow and the truth value is T or 1. Now, if the switch S1 is closed, S2 is open, then it is also light will glow and it is denoted by T or 1. If the S1 is open, S2 is closed, then light glows or lamp glows and it is denoted by T or 1. If both the switches are open or off, then light won't be glow. Another example or another type of the switches is this. Represent the following circuit symbolically and write input output table or switching table. Here it is again. It is a special type of switches. The switches are in series. In the last example, we have seen the special type of switches are in parallel, or these are the type of series. These are the two types of switches. Switches in parallel and switches in series. Here it is again. We know that the lamp L glows if and only if both the switches are closed. If it is possible, in between one of the switches are open, then light won't be glow. Solution: let P denote the switch S1 is closed, Q denote the switch S2 is closed, L denote the lamp L glows. In this case, the lamp glows if and only if both the switches are closed. Symbolic form of the given circuit is P conjunction Q, because here both the switches are closed. The switch S1 is closed and the switch S2 is closed. That's why here we use the logical connective AND conjunction. And in switching table or input output table for this, if both the switches are closed, obviously light will glow, lamp will glow. If S1 is closed, S2 is open, then lamp does not glow. Obviously, the switch S1 is open, S2 is closed, then lamp does not glow. If obviously, say last case, both the switches are open, then lamp will not be glow. Another example, express the following circuit in the symbolic form. Here is the new circuit. First we will study for the switches. Here is the two boxes are there. In the first box, S1 S2 and S1 dash S3 dash are connected in parallel, but S1 and S2 are connected in series, and S1 dash and S3 dash is connected in series, and S1 S2, the switches S1 S2 and S1 dash and S3 dash are connected in parallel, and these four switches are connected to these three switches in series. Look at here. That's why if we denote, let P denote the switch S1 is closed, Q denote the switch S2 is closed, R denote the switch S3 is closed, or negation P denote here the switch S1 dash is closed, negation R denote the switch S3 dash is closed, and L denote the lamp L is on. Look at the figure: S1 S2, S1 dash S3 dash, S1 S2 S3. Okay, the lamp L is on if and only if the switch S1 and the switch S2 are closed, because S1 and S2 are in series. See, switch S1 and S2 are closed, or these two switches are in parallel to these switches, also, or S1 dash and S3 dash are closed, and which is connected in series with these three switches, and the switches S1 or S2 or S3 are closed. The lamp L is on if and only if the switch S1 and the switch S2 are closed, because with the help of the speaker we say that here S1 and S2 are in series, or the switches S1 dash and S3 dash are closed, because S1 dash and S3 dash are in series, and the switches S1 or S2 or S3 are closed, since S1, S2, S3 are in parallel. And the symbolic form of the given circuit is P disjunction Q, disjunction with negation P, negation R, conjunction with P disjunction Q, disjunction R is equivalent to L. See, this is nothing but the symbolic form of these three statements. The switch S1 is closed. See here, switch S1 and S2 are closed, P conjunction Q, or means disjunction. The switches S1 dash and S3 dash are closed. Here it is again negation P conjunction negation R, and this whole box is connected with these three switches are in series, S1, S2, S3. Here it is the OR, P disjunction Q disjunction R, and which is equivalent to the lamp L is on. This is some brief information about the logical application of logic to switching circuit. Generally here L is not written, and therefore the symbolic form of is P conjunction Q disjunction with disjunction of negation P conjunction R, conjunction with P disjunction Q disjunction R. Thank you.